Hello students, welcome to Dr. Shourab's classes. In this particular video, we will be talking about solving the sums from advanced placement calculus AB. And as you can see, this is the free response question, that is the FRQ, which is one of the most challenging part, and as well as it carries a significant amount of numbers. So for those candidates who were particularly worried about this advanced placement part for the FRQ section, and they're willing to increase their marks actually in this overall score. So we have this put a 5-point strategy, okay, so to deal with this particular FRQ sections. So first is the read carefully each part of the question. Next is you have to maximize your points on the multiple part. For case of the multiple part questions, you have to share your thought process. And point 4 is be clear and concise. And number 5 point is usage of proper penmanship. So these are the 5-point strategy. Here I'll be following this 5-point strategy to solve this question from the advanced placement part. And you can see this question number 2, it is from the part A. So this here you have this graphing calculator is allowed to answer this question. It is required to answer this question. Okay, so this question is from 2019. Okay, so let's start with the question. So it's saying that the velocity of a particle p moving along the x-axis is given by the differentiable function bp, where bpt is measured in meters per hour and t is measured in hours. Selected values of bpt are shown in the table. You can see this is the table above, and particle p is at the origin at time t0. So it is increasing, okay, and it is also increasing the same manner. So let's move to the question part A. You have to solve this one by one. So the part A is asking that justify why there must be at least one time t for 0.3 less than equal to t less than equal to 2.8 at which this vp prime t, the acceleration of the particle p, equals 0 meter per hour square, that is the per hour, okay, meters per hour. So that is the first part. So this is part A. So we have this Vp is differentiable. Okay. So Vp is also continuous. Okay. On this interval 0.3 less than equal to t less than equal to 2.8, right? So here we can find that Vp 2.8 minus Vp 0.3 divided by, in the numerator, 2.8 minus 0.3. So we have over here, so this is 55 minus 55 by 2.5, which is nothing but 0, because as you can see that 0.3, the Vp meter per hour is 55, 2.8 it is also 55, so it will be 0, right? So by the mean value theorem we can say mean value theorem, or we can write it as MVT. So there is a value c, right? So this value, there is a value, so there is a value c such that 0.3 less than c less than 2.8, such that this Vp prime of c is equal to 0, right? So that is the part 1. It is saying you have to justify why there must be at least one time t at which this Vpt, the acceleration of the particle p, equals c. Okay. Now part B, question 2b. Use a trapezoidal sum with the three sub intervals 0, 0.3, 0.3 to 1.7 and 1.7 2.8 to approximate the value of integral 0 to 2.8 vpt dt. So this is the part B. Okay. Solving for part B. So first write the integral 0 to 2.8 vpt dt, right? So here we will solve this 0.3. Next we have this vp0 plus vp 0.3. In the numerator it is 2 plus 1.4 vp 0.3 plus 1.7 by 2 plus 1.1. We have this vp 1.7 plus vp 2.8 divided by 2. So putting the values over here, we have 0.3, 0 plus 55 by 2 plus 1.4. It will be coming as given 55 plus minus of 29 by 2, 1.1. It is minus 29 plus 55 by 2. Okay, so here it will come as the value 40.75. So this will be the answer using your trapezoidal sum. Okay, use a trapezoidal sum, right? So this is for part B. Now move to part C. So I will come to at the last what will be the scoring point section. So part C is second particle Q also moves along the x-axis, so that its velocity for 0 less than equal to 2 less than equal to 4 is given by this vq of t, that is 45 root t cos 0.063 t square meters per hour. So we have to find the time interval during which the velocity of the particle q is at least 60 meters per hour. So find the distance. We have to find also the distance traveled by the particle q during the interval when the velocity of particle q is at least 60 meters per hour. So that is the part C. We have to find the time interval as well as the distance traveled. Okay, so let's solve the part C now. So we have this vq t is equal to 60 meters per hour. So from here you can say t equal to a, which will be equal to 1.866181, or t equal to b, which can be equal to 3.519174, right? So vq of t is greater than equal to 60 for a less than equal to t less than equal to b. Okay, so if we do the integral, that is a to b mod of vqt, so it will be the vqt dt. So if it will be equal to 106.108754. Okay, so the distance between the distance traveled. So you have find the time first and then the distance traveled by particle q during the interval a less than equal to t less than equal to b. It will be equal to 106.109 meters. Okay, so first is the t, the time and there is a distance. So that covers the part C. Now the last part, that is part D. So it is saying that at time t equal to 0, particle q is at position x equal to minus 90. Using the result from the part B and the function vq from the part C, we have to approximate the distance between the particle p and q at time t equal to 2.8. Right? So we have to take two answers of part B and C, and you have to find the distance, approximately find the value of the distance between the particle P and Q at time t.28. Okay, so that is the D. So from part B, this position of particle P at time t equal to 2.8 is, we have to find the xp at 2.8, integral of 0 to 2.8 vpt dt. So if you use this, calculate this, it will come out as, that is given 40.75. okay, next is x cube. So x of q at 2.8 is equal to x q at 0 plus integral of 0 to 2.8 vqt dt. Okay, so which will be, it is minus 90 plus of 135.937653. so if we solve it, it will come out, so this division, addition, 45.937653. okay, very simple. So at time t equal to, so at time t equal to 2.8, so the distance between this approximate distance between particle P and Q, okay, it will be 45.937653 minus 40.75 we have, so it will be equal to 5.188 meters apart. So that is the distance between the approximate distance. Okay, we have to find the approximate distance between the particle P and Q. So that covers the part D. Now coming to the point distribution, in the part A we have been given the, okay, so now coming to the part A, so how you maximize your point. So this one fetches you 1 point, and the justification by the mean value theorem 1 point. So 2 points over here. In part B, similarly, just we have find the answer directly using the trapezoidal sum, so that fetches a scoring point is 1. So in part C, we have the, first of all, the interval that we have find t at a and b, so that fetches 1 point. The definite integral, so this fetches 1 point, and the distance, the answer that you have measured, that fetches 1 point. That's 3 points. And the last, finally, for the D, part D, so for this position of the particle P, okay, so this one fetches you 1 point, at position of the particle at Q fetches you 1 point, and the distance between them fetches you the scoring point. So in this way you can maximize your score in this multiple part questions. So this is for the question number 2.